Okay, this is the lecture video for MAT 1100. We're in section 1.5 where we're going to look at different skills for creating a graph and reading a graph. And in particular, what we're going to be looking at is how to decide what we want our scale to be on the x-axis. In other words, how much do we want to assign to each little grid mark that's on the x-axis? That's called the scale. A y-axis also has a scale. Are you counting each one for 5? Are you counting each one for 1? Are you using 10 for each grid mark? That's what we refer to as the scale. So one of the skills we want to try and develop in this section is looking at the table of values that you are trying to graph and deciding how high do the numbers on that particular axis go, so that I know what to assign to each grid mark. And that's what I'm going to be demonstrating. Now, your graphs, they can be there's many different types. You can have a graph sometimes where you go to plot points. You see a bunch of points here. And by the way, I got all this information from your book on page 63, if you want to just look on that page while taking notes for section 1.5. And you see a bunch of gas prices here. That's going to represent our y-axis. This first column is going to represent our x-axis. And the only reason these are here, we're not going to plot these, is just so you can understand that in order to gather all this information, somebody started observing gas prices in the year 2006. So what you see here is 0, meaning that 0 time has transpired. The experiment actually began in 2006. So at that point, no years have passed. You're at time 0 and your gas price is 2.32. And as we can always do, you may have seen before, is we can take our what stands for our x value, pair it with the y value, and we have what's called an ordered pair. X always comes first, the value that stands for x, and the value that stands for y comes in the back, is written in the back. So this is what we refer to as an ordered pair, x first, then y. As we go down this table, you're going to see various values here. And when we finally do create this graph, you're going to see that instead of the points lining up in a straight line, because that's just one type of graph, as I was mentioning, a linear graph, when everything lines up in a straight line, you can have an exponential graph, which kind of has a curved appearance. And I'll talk to you about something that we've been learning about, simple and compound interest, where one has an exponential graph and the other one has a linear graph. What you're going to see here is a bunch of points that are scattered out in sort of a zigzag fashion, and the graph is called a scatter graph or a scatter plot. So there's different kinds of graphs, but the main thing is that we want to try and develop the skill of looking at all the various x values that we have and deciding how much do we want to assign to each grid mark. So if you see that your x-axis goes out to 10, you need to be able to plot numbers that go all the way up to 10. So notice that on this x-axis that you see down here, with the number of grid marks that I had to work with, I decided to let each grid mark stand for 1 so that I could make it all the way to 10. So this first grid, now I'm not numbering every single one, because then the numbers would just jam right into each other and it wouldn't be a nice clear graph. When you label that first one, that already tells the story that each of these grid marks stands for 1. So this would be 1 plus another one is 2, this is 3 plus another one, that's 4 in there, even though I didn't label it. That's 5, 6, 7, 8, 9, 10. And then they don't go any higher than 10. So that was a good, this is what we call an x scale. I'm deciding that my x scale is 1. In other words, each one of these grid marks stands for 1. On my y-axis, since I have so many different gas prices, these are going to be my y values. They're all between $1 and $3. I mean, there's some that are a little higher than $3. So these numbers I spaced out a little bit more. so that I can approximate. When I try to look for 3.09 versus 3.40, I can just go a little bit past 3 to represent 3.09, but a little bit higher to represent 3.40. So spacing them out like this gives me the chance, the opportunity to approximate these decimal type numbers. I mean, I was able to just say every 3 grid marks, and you're the one that's going to decide on your scale. Just as long as the assignment that you choose for each of the axes, just as long as it will permit you to graph all the points. So it has to allow you to get to your highest x and to get to your highest y, which what I have chosen does that. I decided that every 3 grid marks I would call that 1, another 3 grid marks another 1, getting us up to 2, and then another 3 grid marks getting us up to 3. Okay, again, let's go over this table. So the experiment or the observation of gas prices started in 2006. So at the time when we began observing gas prices, 0 years had passed from the 2006 start point, and that's why we have 0 years here. Gas price was $2.32. In 2007, 1 year has passed from 2006. From here to here, 1 year. So the gas went down to $2.27 at that point. In 2008, 2 years have passed since 2006. So you have 2, and the gas price shot up to $3.05. By the time you get to 2010, 4 years have passed. 1, 2, 3, 4. That's why you see a 4 there. And the price went, I think I skipped over 2009. In 2009, 3 years had passed. And this went down to 179. By the time you got to 2010, 4 years had passed, and you're now at 273, and so on. So this is just how many years have passed since 2006. By the time you get to that last number where there's a 10, and that's because 2016 is 10 years beyond 2006. Okay, for each of these, you compare. This first column is always, when they present you with a table of values, the first column is always going to be for your x-axis, and the second column will be for your y-axis. And again, as mentioned, you can take these numbers and place them in what's called an ordered pair when you go to plot them. So now what we're going to do is plot them so that we can see what the shape of the graph is. Okay, so the first point is 0 and 2.32. Let me see if I can make this a little smaller so we can see the numbers and the graph. I can see it a little bit better. Okay, so this first one that I'm going to be graphing is 0 to 32, and you can only approximate on these decimal portions. That's the best that you can do. So if I'm going to go to 0 and then 2.32, I would go to 2, and then I would go a little beyond this. So now if this is 3, if that's $3 right there, then this would be about 30 cents, 60 cents, 90 cents, just so you can get like a little estimate. You can just kind of approximate that way. Like this would be $2.50. So approximating for $2.32, if this is the halfway mark between $2 and $3, then $2.32 would have to be below that mark. Okay, so at 0, we're going to go to about $2.32. I'm going to approximate that right there. So I've done that point. Okay, now I'm going to go to $1, $2.27, which is going to have to be below this because this was $2.32. So go to 1 and then up to your best estimate of $2.27. Okay, then I'm going to go to 2 for my x and 3.05. So now I'm at 2. Go to 2 on the x-axis and then rise up just a smidgen above 3, which will represent our $3.05. And you can connect these points as you go along. Notice that it's going down, and that's because the gas prices went down from year 0 to year 1. And then they went up So this is what we call decreasing and then increasing. They're often going to ask you about the increasing or decreasing nature of a graph. Well, decreasing is when the graph is going down, increasing is when it's going up. We'll label some of these things after we get the points plotted. Okay, so we've done the first 3 points. Now I'm going to go to 3, 179. I'm going to slide this up a little bit so we can see a better view of the graph. So 3 and 179, we're going to go a little bit under. Remember, the halfway mark is right here. This would be 150. So 179, you're closer to 2. And we're pairing that up with 3. You can go like this and connect it from the previous point to the point that we're on right now. Okay, moving to the next one, which is 4 to 73. So 4, we're going to 2, almost up to 3. About 273 is going to be about right there. Go up to that point. Okay, then we're going to go 5309. So 5 would be right here at 3. That point that you see right over there represents 305, so I'll just do it like a little bit higher. Okay, so connecting from this last point to this one, it would look like that. Okay, then we're going to 6340. So we're going to go 26 on the x-axis, and then we're going to go to $3.40. Now, this would have been $4 for me, because I'm saying every 3 grid marks represents 1. So this would have been $4 for me. So 340, which I'm matching up with 6. I'm matching up 6 with 340. Would be about, okay, this is like the halfway mark, so a little bit lower than that. About right there. Just a slight difference from the point before. Then we're going to 7335, and that's going to be a little bit lower than the point I just had, so maybe right there. Okay, then we're going to 8332. 8332. Okay, so that last one was 335, so it's going to be almost right at the same height. So 8332 is almost level with that. Just try to make it look a little bit lower. Then at 9, we're going to 211. So right here would be 2. A little bit above that would represent 211 for me. I'm going to come down. So again, notice that it has a zigzag appearance. It's going up and down. Sometimes it stays pretty level, but this is what we call a scatter plot or a scatter graph. And then the last one is 10 and 197. So here's 10, 197 is going to be just below $2. So right there, connect those, and you're done. Okay, so my X scale was 1. My Y scale, this is my Y scale right here. I'm not going to fit that into the diagram. I'm actually calling this 1/3, 2/3, and by the time I get here, I'm at 3/3, which is equal to 1. So these are actually thirds. And so that is the entire diagram. So a little bit of experience with choosing a scale for your x-axis, choosing a scale for your y-axis, putting these together as a point, plotting them, and then creating the graph. Okay, let's fill in some of these, this terminology down here. It says when reading a graph, we read it going always. Read the graph going left to right. You have to scan it going this way, passing from left to right. And we do that because sometimes you are asked questions about, hey, where is this graph increasing? So I want to tell you that whenever the graph is going up, it's almost like you're riding on a track here that has a roller coaster. When you feel yourself going down on the roller coaster, that's a decreasing portion. When you're going up, that's an increasing portion. So when the graph goes up, that is what we refer to as increasing. And what's actually increasing is the y values. But it's almost like you're on a track riding a roller coaster and you're either going down or you're going up. Okay, when the graph goes down, that's referred to as decreasing. And that's because you have decreasing y values. That's what's actually increasing and decreasing. Okay, so why don't we label a couple of portions where the piece is long enough for us to actually label it. Like if you were traveling right here, you'd be decreasing and then you'd be going up. So why don't we label this piece? It's long enough for me to at least put INC. So here you're increasing from here to here, you're going up. And then as soon as you get to that turning point, you start falling down, going down, down, down. So that would be called a decreasing portions. And I could label every single portion of these, but some of them are so close together, the points, that wouldn't make sense for us to jam it in there. So this is an increasing portion, that's a decreasing. That's a decreasing portion, and that's long enough for me to label it. Okay, so you're going down. And then even when you get here, you're going down. These are pieces where you're going up, and you're going down, going up slightly. Here you're decreasing, and then you get to this point, and then this little section right here, you're going up again until you get right there. So a little bit about increasing and decreasing. If you're going to give answers like this for anything that you are asked on a graph, always go left. Scan the graph going left to right. Look at it that way to answer your questions, or your answers are going to be the opposite of what they need to be. Okay, a good clear graph has clearly labeled scales. If I can't tell what your numbers here, if you don't have nice clear numbers written here, I can't grade your graph. So make sure that these things called scales, which is just the numbering of these grid marks here, make sure that they are clearly labeled with numbers. In the last section, we looked at simple interest, and we also looked at compound interest. And with simple interest, you're actually getting paid the same amount every single month. Once you figure out using the formula for simple interest, we looked at that in the last section. Once you know what you're getting paid on that first year, you get that same amount over and over again. Well, when you go to plot the points that go with a simple interest graph, it turns out, because you're getting the same amount every single month, it turns out to be a bunch of points all lined up in a straight line, whereas compound interest does not work that way. So if we look on the next page, we actually have a picture of compound interest. And this is called an exponential graph. Notice that it has a curve on it. It goes up much more quickly than this type of graph. And you get an exponential graph because the formula is exponential. When you're finding out the amount for compound interest, it is principal times 1 plus rate with an exponent of time. So because this is an exponential equation or formula, the graph has an exponential shape. All exponential graphs have this kind of shape where they climb upward. Whereas what you're seeing here is the same amount of interest plotted for each year. So 5 years, same amount. 5 years, same amount. So this is simple interest, and the points are always going to line up in a linear fashion. This is called a linear graph. There was no exponents in this formula. It was just simply final amount is the interest on the account, which only came from multiplication, no exponents, principal times rate times time, plus your original amount. This is how you figure out the interest, and then you take that interest and add it to what you started your account with. But anyway, when you graph the points for simple interest, you get a linear graph versus an exponential graph for compound interest. So we just worked on the calculations in the previous section, and now I'm just, describing some features for the graph. So the graph of just, filling this in because it continues on the next page. Graph showing simple interest is a line, just a straight line, where compound interest grows exponentially. So we will see an exponential graph, and that's what I just explained verbally. Okay, and that is just a little bit about graphing for section 1.5. That concludes the lecture for that section.